Hello, welcome back. We're going to talk in this video about the individual components in your air supply system. First, we'll do a little vocabulary lesson. What is supply air and return air? What do those mean? Then we'll talk about the ductwork, the different types, sizes, shapes, where they should be located in your building and the different paths. And finally, how does that air get dispersed within the room? We'll talk about grills, registers, and diffusers. So supply and return air, probably pretty familiar with this concept, but supply air is the system that provides conditioned air to a space. It's usually ducted. The return air returns the air or takes the air from the conditioned space back to your mechanical equipment. Right? It's typically not ducted. It will run through a plenum or directly from space to space. And return air is generally needed to maintain air pressure in the building. Why do we return air to the mechanical equipment? For energy efficiency. All right, if you've already heated and cooled some air, you might as well use that nice conditioned air and run it through your mechanical equipment again. That supply air system typically uses ducts. Ducts look like this. There's a couple of really common types, and one is this circular spiral duct, and one is this rectangular duct right here. All right. Your textbook also mentions the oval ducts, which I see less often than these. Um, the circular cross section is more efficient for airflow, but less efficient for fitting into tight spaces, and so the rectangular is more popular for that. This one over here on the right is a flexible duct. You might be familiar with maybe connecting that to the back of your dryer and out to the side of your garage or something. All right. Flexible duct is, at least here in California, not allowed in for your main runs of ductwork. It's only allowed for connections at the very ends between equipment. It's less efficient airflow than the other two because of the corrugations and the many turns that it takes. Ductwork can be insulated. It can be insulated for thermal reasons to reduce heat gain or loss, to prevent condensation. And it can also be insulated for noise control reasons. Noise is often transmitted from one room to another, from one space to another through the ductwork. This is a real problem, right? So for the thermal insulation, that's typically on the outside of the duct. They'll wrap it in this blanket type product, right? For noise control, which also serves as thermal control, all right? The noise control system will do both. You want to put the soft insulation, right, on the inside of the duct to reduce the noise bouncing around through the ductwork. Location. Ducts often run through the ceiling spaces, and in general, it's best to run them parallel to your structural direction and parallel to your lighting fixtures, and that's so you don't add extra depth, extra ceiling depth. Take a look at these two systems from your textbook. You've got a concrete structural system with these beams right here. And if you run the ductwork along in that direction, it can tuck up tightly into the ceiling structure, right? You can see that it's kind of next to this light fixture. If you run the ductwork in the opposite direction, you're going to have to drop it under the structure, and therefore your total depth is much deeper, and you lose some ceiling height. Let's take a look at it in this photo here. Here is an example of, this is a wood construction. We've got some TJIs, um, going in this direction. You can see that when the duct is running along in the parallel to the structure, it can be kind of tucked up in that cavity. But further along here, you see when the duct is running perpendicular to the structure, they had to drop it down below. And so that's going to, maybe they'll have to box it in. Um, it's going to protrude and drop the ceiling height of this particular room. Ducts should always be inside the thermal envelope. All right, if you put them outside of the thermal envelope, um, you get much reduced efficiency of your heating and cooling system. And your textbook notes that above a corridor ceiling or a hallway ceiling is often a good location. Right? And I just wanted to show you that exposed ductwork is often popular for its particular aesthetic. Let's move on and talk about the different types of supply registers. They come in many shapes and sizes, all right, but there's a couple basic types. First of all, a grill. It has adjustable vanes for controlling the direction of air entering the room, right? But you can't open and close it. A register is a grill that has a damper, all right, which controls the amount of air and also the direction of the air. And finally, a diffuser is needed when there's cold air coming in from the ceiling. And that often causes discomfort in your users as that cold air hits their head. All right, and so you would use a diffuser, which is a piece of equipment that specifically mixes the supply air rapidly with the room air. All right, and they, just like registers, they also have a damper. Your return air system is a little bit simpler. It generally leaves the room through a grill. You don't need the damper or the diffuser. Um, but it is possible for the return to be through some of the lighting fixtures, have integrated return air, through perforated ceiling panels up to a plenum area, or specifically in residential, undercut doors. When designing your air supply system, it's often compared to a tree with a main trunk and smaller branches. Let's take a look at this illustration from your textbook. You can see the tree shape as we have the main trunk duct, all right, and then individual smaller branch ducts come off of that. So looking at this other illustration here we have our air handling unit, all right, and our trunk duct, all right, and then individual branch ducts, they're calling them duct pipes for some reason, here we go, in going to your supply air register, all right, and then your return is coming through this plenum back into the air handler. Thanks everyone. In this video, we covered the individual components of your air supply system.